Thank you all. Go ahead, Parinam.
Hi. So I'm
Actually,
Ravin. Oh, sorry, Viva.
I'll just do the announcement and then bring you on. So, thanks all for joining. Appreciate everyone coming into here to listen. Ravin talk about estimating ROO. So, we'll get to that in a minute or so. Just want to make a few quick announcements. So, Datacon LA is in a couple of months. We had a huge selection of submissions that came in, close to about 200. We are still finalizing and whittling it down to the representative number. But just to let you know, it's going to be 3 full days packed with talks. We're going to have several tutorials, several panels. So if you haven't already registered, please do so. You're going to see a lot of impactful talks, panels, and tutorials that will definitely help you in a career, especially if you're going to looking at continuing down data science or data engineering path. With that, I just want to make a shout out to Ravin Audia, who is joining us to present his talk and give us an idea of what he's been doing, especially in this time of COVID, and how he's using his skills to help us out over there. So, thank you, Ravin. And with that, Ravin, you can please feel free to go ahead and start this presentation.
All right. Second time's a charm. Let me pull up the slideshow. So, hello everybody. Like Subhash said, my name is Ravin or Ravin, and I'm going to talk about estimating R naught today. So I know this might be a new term. I'll just jump into it, and then feel free to ask questions anytime. I'm not a very Zoom person, so I'm trying to figure out how to see the Q&A live.
So just based on what Ravin said, if you have any questions, please use the Q&A button right on your panel. Ravin, I'll let you know if there are questions in between, perfect. And so that you can take a look at them.
All right.
Please don't use the chat because I won't be looking at the chat to see if look at any questions. Thanks, guys.
Cool. And Subhash, one last favor: everyone can see my screen? Is that visible? Just before I start going on.
Yes, I think everyone can see it. I can see it.
Perfect. All right. So with that, all the formalities out of the way, let's talk about estimating R naught. So I'm actually just going to jump straight out of the page and show you what we're going to be looking at. We're going to be talking about how this particular website got built. All of you can go to it. It's rt.live. It's up every day. The data is updated in the morning. And as in short, you can see there's a lot of numbers and very graphical type of data things. You've got up here, you have a bunch of bars. Down here, you've got a bunch of time series graphs. And what I'm going to talk through is what all of this data means, how it ended up here, and just through all the ways, the two things, how the tooling we use to get here, but I think, and we'll talk about it, the most important part is how this isn't tied to any particular company. There's no money or anything behind this. It is, I think, at the core of like a data for good project of the type that Subhash champions and how. So let us jump into it. So let me go through a quick intro for folks that don't know me. So I like to call myself a data decision person now. I used to use data scientist, but it's so overloaded that I've sort of switched up the terminology. What I do in businesses and just typically is help strategic decision makers in those organizations decide how their actions are either supported by data or confounded by data or things like that. So like at Sweetgreen, which we'll talk about in a second, how data supports employee happiness, for example, and what we can do about it. So I've got the credentials for the internet. So here they are. I used to work at a big company called NOV. We made these drill ships. And then I worked at probably the coolest company, which was SpaceX, and helped launch this particular rocket, which is Falcon Heavy. Now I work at Sweetgreen, and I work in the salad manufacturing organization. But I think the most relevant thing is I love contributing to open source, and I encourage everybody to contribute to open source. Like spoilers, my talk is going to be trying to convince you to contribute to open source. In particular, I contribute to 2 Bayesian statistics libraries. One is called PyMC3. The other one is called ArviZ. So I'm going to prod Subhash here to put up a poll. I want to get a sense of how many people know Bayesian statistics or have used it, and I'm going to gear my talk a certain way. So Subhash, if you could do me that favor.
The poll is up.
Awesome. So if you guys could help me out with a statistical estimation, in this case, it's a binary estimation of the proportion of people that are familiar with this type of statistics. Let me pull this over here.
I guess we can end it. It's 26 people of 30 voted, so 86% completion. So
okay,
I'm going to end the poll.
What's the ratio?
Okay, can you see
All
it?
right. Yeah, here we go. Okay, seems like most of our audience is familiar with Bayesian statistics. So I'll cover it at a higher level. And if you're part of the know and my talk is a little bit confusing, just I'm happy to talk anytime. So we can do it in the Q&A or we can do it later. Awesome. Thank you, everybody. So back to R naught. Like, what is it? So what I'm going to talk about at a high level is how R naught is being used, how R naught was generated in a way that's getting used by decision makers. So not focusing a ton on the mechanics of the tools, but more so the end-to-end process. In this case, a bunch of open source tools, a whole lot of them, came together with multiple open data sources and multiple groups of people to create the site that you saw that has been used by Andrew Cuomo and the governor of Arizona and many others to make policy decisions. So it's in this case, I find it to be really cool that open data can make its way back to, I would argue, very influential members of American society that are now making policy decisions on it. And this really is like the end-to-end data for good, right? It's not just data. It's not just one group of people, and it's not just one tool. It's a combination of all these things that come together that help out very non-data people, right? Very people that are outside of tech to live their lives in a better way. And I want to point out, no company required. It doesn't. You don't have to be part of a nonprofit to do these things. So there's a little bit of a bait and switch, as I alluded to. We'll talk about our RT.live and R naught and how it's used, but we're going to get back to how you can get involved just in general, not necessarily with RT.live, although you can if you want, but just in general, how this is a framework for getting involved, using your data skills to do stuff, again, for good. So COVID-19, I'm pretty sure people have heard of it. You know, if somebody hasn't, I'll go through it. It's, an infectious respiratory disease that transmits from person to person, and unfortunately it transmits pretty effectively. And so it's, a real challenge with modern society across the globe. The hard part, though, is suddenly it just, it's everywhere. We don't, if you think about a lot of other projects, whether data or not, usually there's lots of experience and there's lots of time and you can ramp into it and you can figure out what you're going to do. With this particular problem, it hit everybody within probably the span of 3 months or 4 months or something about it. So even to this day, we're still not sure exactly what to do about it, right? Ignoring the data, there's still a lot of challenges about making decisions with this very, very new phenomenon. There's a lot of politics. So I think maybe the folks here, I would say tend towards science, we tend towards numbers and logic, but of course, there's a wide spectrum of how people behave and act, and it's not always data informed or logic informed, and feelings, even us, we have feelings. So there's a lot of politics on that's informing what we should do about it. For us data people, there is some data, but it's not a lot of data. So if you think about, let's say, cancer or smoking or HIV, there's decades worth of controlled studies and randomized trials and people who've set up experiments in particular ways to understand those particular issues and how they work. COVID didn't benefit from that. It just sort of appeared, and we have maybe 6 months worth of data, but I think as the hardcore data people here know, we love having years and years worth of information, and having 6 months or 7 months is hard. So given all these factors, how can we use data to help people make decisions, given this is a particularly important scenario? The one way, of course, is historical counts. This is like the Tableau metrics of stuff, and they're good, right? You can count things like a number of deaths, or you can count things of like number of cases, but historical counts don't tell you much about the future. Like they don't extrapolate into the future. A trend historically might not be indicative of what's going to happen a day or two or a month from now. And particularly with COVID, they can be skewed. So there's, for example, a certain individual that has this notion that if you test less, there'll be less cases, which technically is true. So it's good to do the historical count, but it doesn't leave much in the way of being able to make decisions, extrapolate for the future, or control for mistakes in historical counts. The biggest thing, though, and this is what we're gonna talk about mostly, is it doesn't tell you how fast COVID is increasing or diminishing. Getting a count of the number of positive tests or the number of deaths doesn't really tell you whether it's going up or down in the population as a whole, and particularly it doesn't tell you how fast it's transmitting between people. This is not to say historical data is not useful. Of course, it's very, very useful. As data folks, we love historical information, but of course, it doesn't tell you everything. It's not a forecast. So what we specifically want to know is this concept called R naught. And when I say we, I mean this is the people who put together RT.live. RT standing for R at a particular time step. So we believe that an interesting number in the COVID scenario, in addition to the historical counts and everything like that, is this epidemiology definition of transmissibility and how fast particular diseases are multiplying. So if we had an R naught of 2, this means that one person would get sick and they would infect 2 other people, who would then infect 2 other people, who would then infect 2 other people. For the mathematical people in here, this is exponential growth. So you understand this is going to get quite big, quite fast. If it's 2, but the question is it 2 or is it 1.1 or is it 1.3 or is it below 1? If it's below 1, that means this one person will infect 0.8 people, which will then infect 0.8 people, and the disease will go away. Maybe the more intuitive way to think about this is if this R naught was 0.5, if there were 100 people with COVID, they would infect 50, and then at the next time step, those 50 would infect 25, and slowly the disease would go away and diminish, and we wouldn't have the issue as much as we have now in America. So knowing this R naught number really gives you an understanding of whether the measures we're putting in place, which we'll go back to, are helping reduce the virus spread or whether we're increasing the virus spread. And again, different than historical counts, this gives us a notion of how fast will this spread in a population over time, and if we extrapolate a little bit, whether it's expanding in a population over time or not. So there's a chart on Wikipedia. I don't have it here, but it has the R naughts for various diseases. It's quite interesting to see, to compare this to like measles or the others. So I guess the important thing I should point out too is R naught just doesn't calculate itself, right? Like it's not like there's like a magical R naught table where like select star from R naught, where R naught equals like or whatever. This has to be estimated from the data that we get from back here because we really only have a limited amount of data. How can we get to this particular number? So as you may expect it, Bayesian statistics is what I'm going to talk about. If we ignore any of the COVID stuff for a second and we just focus on algorithms, which could be fun. Bayesian statistics is a super flexible algorithm. It's actually literally just these 4 terms. And it lets you, even though it just seems like it's 4 terms, it enables a way to describe uncertainty in mathematical equations, and particularly what's called the directed acyclical graph that takes events and ties them to other events with another probability and ties them to another events a probability, and lets you say that like if somebody has been traveling a whole bunch and is a smoker, their risk of lung cancer might be high or the risk of COVID might be high versus if you have somebody that exercises a bunch and stays at home, their risk of both lung cancer or COVID could be low. I'm not going to go too much into the Bayesian modeling specifics in this particular talk, but I can talk about it in the Q&A. I say the big things that we care about out of this is it provides uncertainty natively. So instead of just getting a point estimate, like a stranded linear regression, you get uncertainty around all of your estimates, which is super helpful when trying to make decisions. It's actually a big reason I use Bayesian statistics for helping organizations make decisions. And in particular, with our particular COVID problem, it works really well with small data sets. We'll put with you in here twice, but some algorithms, like let's take neural nets, for example, require enormous amounts of data to train well and perform well. It's not the case with Bayesian statistics. You can get by with 10 or 20 or 30 observations and still have good characteristics from your estimates that give you more information than if you didn't use Bayesian statistics. So what we want to do is we want to use Bayesian statistics to build a model for R naught. And I've put the model architecture here in plain text. But essentially, we want to start with the number of reported positive tests. So reported positive tests both has the number of positive tests and the number of tests in general. That's really all we get, or most of what we get from a lot of these tracking projects. Now, the first challenge, as we talked about before, is the number of positive tests is going to depend on the number of tests you have. So if you test very little, you won't have very many positive tests. If you test a lot, you're going to get many more positive tests. But independent of whether you're testing or not, the disease is spreading in America and in different countries. So how can you get along this bias? So one of the strategies we took in this model was to scale the number of reported positive tests to the number of positives that are in the society if testing was constant. So we make an assumption that if testing was constant, what would the number of positive tests we would get be? That's one estimate. Then the next challenge is that positive tests don't come in at a regular cadence. Like maybe a lab dropped off a whole bunch of batches on one day and you suddenly get a huge spike. That doesn't mean a bunch of people got sick that day. That just means that they happen to get processed that particular day. You also have weekends, right? Like there's a lot of testing during the week when people are normal and at work, and there's less testing on the weekends. But that doesn't mean people aren't getting sick on the weekends or COVID is going away on the weekends. It just means there is some sort of organizational process that's adding some noise to your data. That's another correction we'll talk about. And the last one is a correction for the number of correction of symptom onset. So if I test positive for COVID today, I actually got infected maybe 3 or 4 or 6 or 7 days ago. So just counting the day that the test came in doesn't tell you the spread of it lags with the spread of the disease. So we need to correct for this as well. And this is all these are baked into a model. If I just had an XJ-Boost model, it would be hard to describe my problem in this level of fidelity with this level of causal relationship. Because if you take an XJ-Boost model, or let's say neural net, each factor is largely independent from each other, and the algorithm it does eventually connect things together, but it takes a lot of data to do so, and maybe in a crude fashion. With Bayesian statistics, we as model designers can design a model where we encode these relationships to the computer, which is how it's able to so effectively use small amounts of information. So once we make all these corrections, and not all these corrections, but once we code all these relationships, we go from data to a curve, which gets us to R naught, that reproduction number that I'm talking about. So here's what it looks like in graphical form, and we're going to go backwards. So this jagged line is the number of positive tests. As you can imagine, like we talked about, it's not smooth. It has weekends, it has testing delays, it has all this sorts of stuff. So the first thing we want to do is figure out the number of expected positive tests if testing was constant. So I think intuitively, without any information, like in America, this is the curve for Massachusetts. So we didn't expect a bunch of COVID cases back in January, February. It hadn't reached here yet, but we've ramped up. The number of COVID cases ramps up as more and more people get infected and infect more and more other people. Ideally, you'd want to see it ramp down. Not all states have this characteristic, as you'll see in a second. But we want to scale for the number of tests that occurred. So this orange line is this gray line scaled for the number of tests. Of course, then we want to smooth this out because people don't tend to get infected like with this sort of jagginess. It happens more organically. So the next level is to get this blue curve, which is denoised. A really good example is Massachusetts for some reason had, I think we're all data people, you always have these aberrations that come into large data sets. 4,000 people seem to have got infected in one day. Like, not likely, probably didn't happen. So this blue curve tends to smooth out what we would expect from the positives. And then lastly, the green curve is the time shift of the blue curve with a particular convolve function. So these people perhaps that got sick here actually got sick somewhere in maybe this range. And this green curve is what we're looking for. And what R naught is it's largely the slope of this green curve, because it's telling you whether the virus prevalence is increasing and then whether it happens to be decreasing. There's a link here to a post by Thomas Wiki. It goes into much more detail about the model. What I will do to show you the model, and we won't go into too much into it, is all of these relationships are encoded in this one particular Python class. So in here we have, and in particular in this model. So this is the Bayesian model here with PyMC3. We have all the various transformations that we just saw. The infection curve, the adjustment of positives, an estimate of exposure, and then somewhere in here we're gonna get the R naught. It's all of this code in particular that's doing all the math that you see. So I think it's not a lot of code lines, which is good. Unfortunately, it does have a lot of weird Theano stuff and specific syntax that you need to know to effectively use this particular to get actually a model that's this deep. But if you understand the math and you understand the PPL, it's not terrible to write it down, which is pretty nice. So let's continue on with our presentation. So that's RTlive. Actually, let's go to the site. That's what we see on the site here. We see the estimated, let's use California. We see the estimated reproduction rate. Here's California. And with Bayesian uncertainty, actually, the virus at our state could either be decreasing or it could be increasing. It's hard to tell. Again, the uncertainty estimates make it provide some context by letting you know that, hey, it's close to 1. In this case, it's 0.98 as the mean, but it could go either way. So we're still sort of by the edge, by the boundary. For instance, if we take Alabama or Hawaii, it tends to suggest that Hawaii has a pretty big problem that their policymakers should get on. And with this particular day, Alabama seems to be doing pretty well. If we look at things over a time series, you can see some of these policy decisions. California started this shelter in place and the curve largely dropped. But as we started to reopen, it started to spike back up and then we started to go back down. Nevada is one of my more interesting states because they really were going for it and then they stopped. Nevada started the shelter in place. They closed out the casinos. I think the mayor of Las Vegas decided to reopen the casinos and it spiked back up. And then I believe the casinos started requiring masks, in which the curve started coming back down. So this is how policymakers can get an idea, not having to worry about the math, not having to worry about the data of whether they need to enact stricter regulations or remove them or whatever they happen to decide to do. If we click in, you'll see the route count data. That's the number reported positive, the number reported negative, although it's implicit, might not being showed, and then the curves that are associated with denoising the data, and then the infection curves. So the hope is we can take the COVID model data and put it together in a way that ends up being really clear and use statistics to infer more than is available just from the counts. So how does this all happen? This is one example of a data for good project. It was honestly, it's just a group of many people. It's a combination, like I said, of tools, some motivation, and some data to make it happen. And I want to keep saying that this is one example, but there are many examples. What made this possible in one sense was the science tools. We focus on this a lot. It's the TensorFlows and the PyTorches and stuff like that. This particular model used PyMC3, and of course PyMC3 is supported by a whole bunch of different software. So thankfully there's open source and there's really good people in the world that write really nice code and hand it out for free. So anybody can really largely download it and use it. So that's one piece. But I mean, to make this project, it's not the only piece, right? This model runs every morning pretty automatically. So for the data engineers in the room, this is a very unsurprising picture. You've got another open source project, Apache Airflow. And I don't believe Docker is open source, but it supports the open source community so much that I've just included it anyway. And so what happens every morning is the data gets downloaded from COVID tracking. It gets thrown into S3, or AWS S3, and then it gets an Airflow model will kick off and run. It'll process the data. Oh, sorry. Here you go. Spin up cluster, download the US data, process it, and then run 50 parallel processes for each state. Once we get the results for that day, it does all of the work to clean it up and publish it to the front end. So there is a blog post by Mike Krieger that explains the mechanics of this. For folks that know Airflow, this is a dead simple DAG. There's not much to it, but it's a good explanation for people that want to see how models can be productionized very easily. And yeah, I know AWS isn't open source, but we'll just give them a free pass on this one. They just happen to be everywhere. So hopefully you'll excuse me for that one. But it just doesn't end with the compute. The layer on top of that is the D3 and Next.js web framework. So the website is built in these two technologies, and it combines the science, so the math and the results and the data, and it combines the computation, which is the Fargate containers that are doing all the math and science and computation, but putting it into a way that lay people can interact and view it, and doesn't require you to like pull up a Jupyter notebook or something like that to look through. So again, more open source technologies that are being used in the stack to get information out there. And so this is the data for good, right? It's not like one or two people made this project happen. It literally is hundreds of people's contributions to all these tools that got us there. Of course, now a dedicated group of people took all these tools and put them together and made RTlive, but of course it wouldn't be possible without the support from anybody. And so data for good doesn't have to be like you're directly impacting a charity like yourself, or you're the person that's putting together the model that's directly affecting the customer. Data for good can be developing tools that allow folks to do good work. And there's hundreds of open source tools that I'm sure all of you use. So providing contributions and help with those tools may be helping somebody else do good for the world. And so I promised this would be a what about you? And so I want to stress for like the 10th time, you can get involved in data for good. Literally, I'm using the word data for good because Subhash coined it, and I think it sounds really cool. But like Subhash is a prime example. He's created this organization out of Big Data Day, which became Datacon, to bring together folks to help out and do data for good across the stack. So whether you're a marketing person or a web designer, or you're just getting started in data, or you're an expert in data, like there is a place for you. You don't have to be the principal data scientist at like some company to be able to contribute. The point I want to keep stressing is that there's so many components to making data good and work for people in a good way that really should look around and try and get involved in any of these teams. And so I just want to leave you with this. I know for me, COVID's been challenging. It's been there's a lot of things that are going on, not just with COVID, but with an election coming up, or with racial justice, or any of these. I think I just want to point out that everyone here has the ability to make change in their own way. Like I'll point out, I'm not a great politician. I don't think I could stand in front of a podium or a microphone and convince people through words. But I think I can do it through data, and that's the avenue I've got. So for all of you, I wish you the same. See where you can get involved and how. You don't have to work at a company. It doesn't matter if you just got laid off. Like I'm sure you have some skills where you can come in and affect change in a way that's authentic and meaningful for yourself, and hopefully in my case, with data. If you're interested with Bayesian Methods, I'm going to make two pitches here. So this is like my sponsor me portion of my YouTube cast. Subhash is doing Datacon in October, and later on in October, we're running PyMC for the PyMC project in particular. So if you want to learn more about PyMC stuff and Bayesian Methods, there'll be this whole thing. Of course, you can always go check out the docs. The YouTube videos are things that have already been published. And then me and a couple of co-authors are writing a book about Bayesian methods. So if you're interested in the book, you can sign up. This chapter, Gaussian Processes, is actually the math that was used to develop RTlive. It's built on a Gaussian process model. So we're hoping this book makes it accessible for audiences to understand how computational tools can be combined with Bayesian methods to provide results like the one you've seen. And that's largely it. That's my presentation. Happy to take any questions. I'm going to hit stop share so I can see them.
Ravin, you want to do the second poll before you get into questions?
Sure. Yeah, let's go for it, Subhash.
Okay, here you go.
So I'm hoping I should have done two polls. I'm a bad data scientist because I didn't run a control. But let's just see. After this presentation, are you more interested in working on social good projects? Doesn't have to do with data. It could just be in general. I'm gonna put a yes. I'm always more interested, but let's see what the consensus is. All right. Hopefully that was enough time.
Yeah, I think we have just about 45 seconds, and we have 81% voted.
All right.
So let me share this. Can you see it?
Yeah.
Cool.
Oh man, 50-50. So I hope the rest of you feel like oh, so are you working on any social good projects? Right now we got 54 yes and 47 no. So I would say for the 54 that are going for it, awesome. Like keep at it. That's great. Find a way you can fit it in your life. And the folks that say no, I hope it's not because you feel like there is none or there's none that you can get involved with. I want to again stress that if you feel like you have the time and the headspace and all of that to contribute, there are so many different ways for you to get involved in a data aspect, or even as simple as it's gonna sound like a government worker now, but even participating in polling or the census is a great example of a very classic example of how data has been used in this country for hundreds of years to provide good. So there's tons of opportunities. If you're lacking, talk to Subhash. I'm sure he's got a ton of, actually I know he's got a ton of ideas. So talk to Subhash, and certainly if you feel like you can't talk to Subhash, which I would be surprised by, I'm available as well. But yeah, I just can't stress. Getting involved is great. Makes me feel great. You're gonna help other people feel great. So
Hey, Ravin, do you mind pasting that URL for your book? I think there's a question that came up. I don't think people had a chance to click on that. Oh, there you go.
there's that, and I'm
Actually, you pasted it to all panel. Can you say all panelists and attendees?
oh
Because
yeah.
yeah, it's only I saw it.
All right, let's do it. Let me post Subhash's form. So that the first one is Subhash's data for good form, and the second one is book interest. So I think you all have that. And then
Awesome.
while we're here, I'll just post this whole presentation. You guys can, I'll take
Uh,
a look.
hey guys, if you have any questions, please use the Q&A button to start answering your question, posting your questions. Ravin, looks like there's a second question that came in. If you want to look at it, you can just read out and then give you your answers.
So what's a resource to get started on data for good projects? Is there a registry on projects looking for people? So I'm going to blatantly say Subhash is running data for good, and I'll actually let Subhash, I feel like you can make a much better pitch than me about data for good.
There's actually this project COVID. I mean, obviously what uh, Ravin mentioned, I mean, we're doing data for good, but then there's also this project called COVID-19. Here, let me pull that up. That actually COVID-19 now. Uh, I gotta look it up. Sorry, I had it on my mind. Just
No
the other
worries.
day I was looking it up. Do you remember, Ravin, this site where they're gathering all the COVID-19 projects?
I don't know COVID tracking. I forgot
Oh,
the one.
help with COVID. That says help with. Yep, I found it. Help with COVID.
Oh, this is a good one. Didn't even
Right,
know about this one. I'll paste it
here
in
you
the
go.
chat here.
So there's helpwithcovid.com/project. So that's a good site if you want to go and just focus on COVID. They actually have, you can register yourself as a volunteer and put yourself in for any kind of aspect of where you can help out. They look for project managers, data people, tons of places. I mean, so it doesn't necessarily just have to be focused on certain areas. Even non-technical people can also help out over there.
To answer the question a different way as well, if you maybe let's say COVID is you want to help out with COVID, or you want to do something else, just again contributing to open source projects is a really good way to help with data for good. All data projects use open source projects at this point, whether it's Airflow or Pandas or Kubernetes or a ton of these things. So if you're both interested in helping other people out and advancing your career, jumping into an open source project and contributing documentation or helping answer questions or contributing code directly is a really, really good way to help everyone that's using that tool, whether it's, just literally help anyone who's using a tool and also help yourself ramp up on that particular tool. So that's the other big way I would suggest in getting involved.
That's a good point. Thanks, Ravin. So for the rest of you, I mean, if you guys are interested in asking questions to Ravin, please use the Q&A bar to do that.
Any other questions? I feel like there's got to be one.
Yeah, there's got to be some more questions. We got a lot of great data science people in the room I'm familiar with, but nobody's asking any questions. Should I start calling out names?
Sure. Yeah, Subhash, this is your meetup. You run it however you want.
No, I'm wondering that should I call out the attendee's name? I don't want to put them on the spotlight. We'll just give them a chance.
All right, Muhammad's got one. The frequentist approach is not applicable here. So here's it's hard because typically the approach with frequentist is comparison studies, like with two groups. So let's take cancer, for example. A group of 100 people have cancer. 50 of them get the experimental application. 50 of them get the experimental treatment. 50 of them get a placebo or something like that. And then you can compare like between the groups, like a t-test type of thing, right? With COVID, turns out it's really hard to make a control group. A lot of people have COVID, and it's pretty difficult to and unethical to isolate people in a way that the statistical frequentist approaches will work. The other challenge with frequentist approaches is they can require a lot of data to come up with the significance bounds that researchers and them tend to look for. And they sometimes make assumptions, and the simpler ones, about stationary distributions. The hard part with COVID is nothing stationary with COVID. It changes every day, with policies and travel and countries banning each other and masks and things like that. So Bayesian approaches can handle a lot of that and provide the uncertainty when their estimates are not good. So they tend to excel for this type of problem. Small data sets that have big consequences where you need uncertainty bounds. So hopefully, Mohammed, I answered your question on why Bayesian statistics, I believe, are more useful than frequentist statistics in this particular scenario. I would personally go as far to say Bayesian approaches are almost always better than frequentist approaches, but that's just me. I'm very biased in that sense. So not everyone agrees, but yeah. Any good trainings or course suggestions? I would say I can answer a couple, and I'm gonna type them in. There's a good book. Actually, let me share my screen so people can see the stuff. I might get there faster. So one of the best textbooks right now, Bayesian analysis Python. Here we go. So this book from Osvaldo Martin is a particularly good one to getting ramped in. So if you know Python and you want to get ramped into Bayesian statistics, I find this to be great. It has actually all the tools that I use in this presentation and goes into Gaussian processes, which is what was used to build this model. So let me throw this in the chat for everybody. Oh, that actually closes the question. So here's that book. And then another really, really good book is this one called Statistical Rethinking. Actually right here. The second edition of this book is quite excellent as well. It's written in R, not that that's a bad thing. You want to get the second edition, so I'm gonna paste the first edition, but please don't get the second one. And that's how I would get started. Those are the two things I would get started on. The courses right now, a couple of my friends are making nice courses that are more interactive. When those come out, just ping me and I'll let you know when those come out. And so you can go through those. How do you get started with open source? It feels like projects in Airflow require deep understanding of the code base, and working on smaller projects, you often feel like you're working on a project in a year or two that dies in a year or two. Yeah, so this is a hard part. Smaller projects, you're right, may feel like they're going to die or they're not going to go anywhere. you just maybe good at estimating whether it's gonna work or not. But I'd say the point I want to make is bigger projects with pandas and Airflow. I want to make the argument, and I'll really strongly make it, is you don't have to have a deep understanding of the code base. Actually, it actually in some cases is really good if you don't have a deep understanding, because when you go into code and you read it and it doesn't make sense, that is bad. Like anyone should be able to go in and read Airflow code and what's going on. And if it's not clear after a reasonable amount of time, those library maintainers have done a bad job of creating documentation. So your first PRs can be better documentation, and you're actually better at it than the maintainers, because the maintainers know their code base so well, they forget what it's like to ramp up into their code base. So you have a very valuable perspective that they don't have, and it's a really good way for you to provide value really quickly. So I'd say the two things that help the most, write documentation. If things are unclear as a beginner, you're going to be better at understanding they're unclear than a maintainer who feels like they're clear, but they're not. So that's my first path. My second path would be writing tests. Writing tests is an easy way to help out in the code base that is not dangerous, because you're not going to break the code by writing more tests. You're literally just making the code base better. So find out where something doesn't exist in a test. And by writing a test, you're going to learn how the code works, which then helps you make contributions to the core code itself. So, okay, so that's my answer for open source testing and code. Can you talk about the process that Kevin Systrom from RTlive talks about in his blog post? Can you also talk about the standard deviation that's used in updating the process from one step to the next? I don't know which blog post Kevin Systrom wrote on this, so I'm going to have a hard time answering that question. If the process is Gaussian processes, Gaussian processes are a particular type of model. I'm just going to pull up the Wikipedia page. And so this is the core math that is being used underneath the hood to estimate the R naught number. Here's an example of a Gaussian process. In short, a Gaussian process doesn't assume a particular type of function. So it doesn't assume a cubic fit or an x squared fit or anything like that. It assumes, it doesn't have, it has a non-parametric assumptions, but it tends to do, how do I word this specific way? It tends to, quote unquote, look for clusters of points and fit a line to them that doesn't have to fit a particular distribution. How can you choosing a standard deviation that's using the update process from one step to the next? So to answer this at a high level, Gaussian processes have some not assumed parameters, but you have to put some parameters in there for it to figure its fit, whether it's like super wiggly or super small. There's not blanket advice. You have to, these are like hyperparameters in XGBoost or neural nets or anything like that. You sort of tune them to what you need. It's a different sort of tuning than grid searches, because it's a Bayesian process, which makes uncertainty estimates over those parameters. But hard and fast, you set a prior. Sorry, the short answer is you set a quote unquote prior of what you think is reasonable. The algorithm tends to make a fit on what it thinks is reasonable, and then as a statistician, you go in and you check those assumptions. I know that's a lot of words. It's going to be tough to explain Gaussian processes in 2 minutes. So whoever the anonymous attendee was, I hope that answers your question. Of course, please feel free to reach out if I can elaborate further. Thank you for the presentation. I hope this is not off topic. I'm curious about data science and public health from a philosophical perspective. Are there any conversations or resources around this? So I'm going to say this. I'm not an expert in this. I think I'm an expert in data, but I'm not in the health field. So I'm going to answer from my tangential experience that I've seen from either conversations that I've just happened to be a part of and people that I know about. So data in the public health space is a little tricky because of the HIPAA laws. Let me find that. I always forget what HIPAA exactly stands for because I don't deal with it so much. But okay, yeah. This Health Insurance Portability and Accountability Act. Essentially, what it means is that when you go to the doctor, there's a lot of rules and regulations about what the doctors can release publicly. So from a legal perspective, there's a lot of rules. From an ethical perspective, there's a lot of rules. So it's from the philosophy of ethics, releasing publicly everyone's health records to the internet would be probably pretty unethical. And a lot of people agree in law that it's unethical, which makes health research challenging. But I've noticed that there's a lot of companies that have started to get smart and get around this. So one company that my friend works at is called Flatiron Health. And what they're doing is they're an EMR company. They're electronic medical records company, which lets them collect people's electronic medical health legally. But now that they have it, they can do a lot of research on the records that they're getting, which is what they're trying to do. From what he tells me, they're trying to come up with a new way of understanding cancer from the cancer treatments that occur from oncologists and the field, and not from controlled studies. So maybe to loop back to an earlier question, a lot of the ways that drugs get approved is through controlled studies that are pretty tightly regulated from like the FDA and things like that. It's actually a good thing that they're regulated, because we don't want crazy treatments like bleach or UV light or anything like that. We want hopefully data tested treatments. But that path requires many years. It requires controlled studies. It takes a long time to get a drug to a market. This company, Flatiron Health, sees an opportunity to collect data, health data, in a different way to get drugs on the market faster. So for the very broad question, there are conversations and researches. Bioinformatics is like a huge field that's continuing to burgeon and get larger. And if you're interested about data in the health space, it actually seems like one of the cooler places to go into. I think we can all agree that recommendation systems on Amazon or ad systems on Google are pretty well covered these days. Like, people know how to recommend movies and serve ads, but understanding how to make decisions with health is a very cool, relevant, and open topic that I encourage anyone interested to look into. Those are really good questions. I think people should keep them coming. I think we have 10 minutes, Yuvash, right? So there's still a lot of time for a couple more.
Yeah, if anyone else has a question. Nuri, I saw you posted a question. If you want to post it in the Q&A, because Ravin could answer it.
Why am I excited about the future of data science? I'm a firm believer that if data paired with humans, decision making is like better than either one of them independently. So I think we've all seen examples in neural nets making really dumb predictions. They make a lot of predictions, and most of them are good, but they sometimes make really dumb ones. And then humans, of course, we have our own biases. We can't consider all information, but I feel like if there's a way to combine the two in a way that's effective and seamless, that society as a whole can sort of move up. And the reason I feel this way is, I mean, there's 200 or 300 years of history about it, right? Like the early astronomers like Galileo or like Newton or some of these early researchers, I mean, they had data and they used that to create theories, and that then ended up creating all the things around us, right? Now, because of Galileo, now we can launch rockets to other places, and someday it's possible to go to the moon. So I'm hoping that we are just continuing this trend where we use mathematical tools and logic and reasoning. Now we use advanced ones like TensorFlow or big desktop computers and GPUs, but use these tools so humanity can keep moving forward in all the directions that have served us in the past, and I believe will continue serving us in the future. So, good example again. I really hope there's a future where data can help with this COVID problem, and I really hope there's a future where we can use data to make more equitable decisions for folks like George Floyd or folks of those communities that are underrepresented, like using data to help them have a voice and help make good decisions to help those people out. So that's why I'm excited about data. I really hope it brings, I want to say, sanity and objectiveness to the conversation. I think anyone that's in data knows how idealistic that is. There's a lot of challenges to be solved, but I hope it gets us that way. Nuri says, how do you estimate the error stemming from the assumptions? So the nice thing about Bayesian statistics is that it estimates error as part of the analysis. In short, you specify prior, you give it some data, and then the model itself is able to understand and estimate the uncertainty. So the example here, if I go to RTlive, the model is making largely the assumptions about the uncertainty in these predictions from the data it's seeing. Once it starts seeing a lot of data, maybe a lot of days where you're under one, it'll start, like, here's a good example. Alabama's been pretty flat for a while, so the model's getting more and more confident that the R naught number in that state is below 1. You'll see some other aberrations you'll notice here if you peek really closely. When you're far away from the middle of the data, the uncertainty estimates tend to increase. but when you're in the middle, the uncertainty estimates tend to be stronger. That's because in this particular example, the algorithm can look both ways to figure out where it fits, but at the end, it really only has one way to look. The point being, for Bayesian analysis, it's in the core mathematical model that you saw with the 4 terms, with the prior, the likelihood, and the posterior distribution. There's multiple chapters in rethinking in Python, Bayesian analysis in Python, that explain this with more fidelity.
Hey, Ravin, I have a question for you before you get into the next one. How about you give us your experiences for working for Elon Musk?
See, there's a lot of uncertainty with working with Elon Musk. Elon, I think I'll put it this way. I think the media gets Elon wrong, or like if you're outside of Elon's companies, you tend to get it wrong. He's a celebrity in a lot of respects, so people's experiences with him tend to be very extreme, so you get a wide distribution. But working for him, he's a very good visionary. He knows what he wants to do, and he's actually very good at execution as well. So some people are great visionaries, some people are good at executing but don't have great vision. Elon has both, but he also is very insistent that you meet his timelines for vision and accelerate them and things like that. So he really wants to get a lot of things done really fast. In a lot of respects, he has, right? SpaceX in 18 years has gone from a startup to a company that is now dominating the launch industry, and he's soon going to dominate the internet industry pretty soon here with Starlink. And Tesla, of course, it's actually the most valuable car company. I think I'm actually flabbergasted at how crazy Tesla stock is doing. So working for him is a roller coaster ride. But like for me, at least, with like every roller coaster ride, I want to get off at some point and live my normal life. And that was my experience working for SpaceX.
Awesome. Thanks, Ravin. Can you get back into the questions?
Yeah. And let me go through them a little fast since we have 5 minutes. After you build something, how do you get to where people know about it, use it, see it, benefit from it? Are there any organizations, formal or not, that you can that can help? Any suggestions? So after you build something, I think something data people are bad at nominally or terrible at is you need to market it a lot and spend a lot of time marketing it. Just ask Subhash. Ask how much time he spends marketing Datacon LA. Right? It's not like Subhash just creates the conference and it like magically grew every year. Like Subhash and all the volunteers put a ton of work into marketing it and branding it and making it look good. And it's not very data-y, but it is very crucial when it comes to getting people to know about and benefit from your project. Are there any organizations? So again, Subhash has got one, Datacon and Data for Good, that can help. I will say I learned a lot by helping be a part of the Datacon planning process. I learned how important it was to do these. So I'm going to, again, pitch Subhash and his organizations as one really good ones to get into. And yeah, that's my answer. Go hang out with Subhash more. He's really good at it. He got a certificate from the city of LA because he's so good at it. Do you know any other projects similar to RTlive that cover data from the rest of the world? So the RTlive model is open source. So some people have converted it to other countries. RTlive.de covers Deutschland, which is Germany for us. And so it's the same model. You'll see that these graphics look very similar. And that particular person, Michael Ostrich, in this case, he took him and his I forget the name of his that's right here, Laura Helix. Both of them took the RTlive model and they converted it to work for German states. So somebody else is also trying to do this for France. If you've got a country in mind and they have case counts, they have positive case counts and test counts, you can take the model and regenerate this for in any region you'd like. I hope that helps. Nishas, what's the best way to reach me? I think the easiest one is probably Twitter or LinkedIn. I didn't think I put my LinkedIn profile up there, but I think you can search for it pretty easily. But you just message me on Twitter, and I'm sure we'll find one of like the 50 channels to get to me. I will say I'm not checking Slack as much these days. If I want some Slack group, I'm trying to like disconnect from the internet a little bit. Life is pretty tough. So just message me on Twitter or LinkedIn, and I'll get you. I think with 3 minutes left, I think that's good. Subhash, are there any like closing thoughts, or should I?
Oh yeah. So just quickly for you, everyone out there, our next panel is going to be on September 10th. We're going to have Anita Sengupta talk about the future of electric flight. So if you're interested in learning more about what the future looks like and how flight is moving in a different direction compared to what we have today, that would be a great session to attend as well. September 10th again, it's the event should be posted on Datacon LA email group pretty soon, so you'll see that. We'll also post this video in a day or two on your YouTube channel. If you are not aware, just go to the YouTube and search for Datacon LA. You should be able to find the channel pretty easily. Other than that, I think that's all I have. And if you haven't registered, no, please make sure to register for Datacon LA.
Cool.
Awesome. Thank you, Ravin. Appreciate everything. Thank you once again for, sharing your thoughts and your great presentation. And thanks everyone for joining. Hope to see you guys again pretty soon.
Thank you, Subash. All right.
Thank you.
Bye, everybody.